Good morning everyone. Today we are going to discuss about input and output characteristics of a transistor in common emitter configuration. So a transistor in a common emitter configuration has two important characteristics, namely input characteristics and output characteristics. Okay, first let us see input characteristics. So the input characteristics curve gives the relationship between the base current and the base to emitter voltage VBE for a constant collector to emitter voltage. So, these characteristics may be obtained by using the given circuit as shown in the figure. First of all, we adjust the collector to emitter voltage VCE to 1 volt. Then we increase to base to emitter voltage VBE in small suitable steps and record the corresponding values of base current at each step. If we plot a graph with the base to emitter voltage VBE along the horizontal axis and the base current IB along the vertical axis, so we shall obtain a curve marked as VBE equal to 1 volt as shown in the figure. A similar procedure may be used to obtain the characteristics at different values of collector to emitter voltage, that is VC equal to 2, 10 and 20 volt. The input characteristics gives us the information about the following important points. The point 1 is there exists a threshold or knee voltage below which the base current is very small. The value of knee voltage is 0.5 volt for silicon and 0.1 volt for germanium transistors. Okay, so beyond the knee, the base current IB increases with increase in base to emitter voltage, that is VBE for a constant collector to emitter voltage. However, it may be noted that the value of base current does not increase as rapidly as that of the input characteristics of a common base transistor. It means that the input resistance of a transistor in common emitter configuration is higher as compared to the common base configuration. Okay, as the collector to emitter voltage VCE is increased above 1 volt, what happened? The curve shift downwards because of the fact that as VCE is increased, the depletion width in the base region increases. That reduces the effective base width, which in turn reduces the base current. Okay, so the next point is we observe from this graph is the input characteristics may be used to determine the value of common emitter transistor AC input resistance, that is Ri. Its value is given by the ratio of change in base to emitter voltage, that is del VBE, to the resulting change in base current IB at a constant collector to emitter voltage. So mathematically the expression can be expressed as Rf is equal to del VBE divided by del IB. So it may be noted that the input characteristics is not linear in the lower region of the curve. Therefore, the input resistance varies from the values from 600 ohms to 4000 ohm. And the next characteristics curve is output characteristics. So this curve gives the relation between the collector current IC and VCE, keeping IB constant, is called as the output characteristics of a transistor. So this is the circuit diagram of common emitter configuration for observing output characteristics of the transistor. So these characteristics may be obtained by using the same circuit. So to begin with, adjust the base current IB at 40 milliampere value. Then increase the collector to emitter voltage VCE in a number of steps and record the corresponding values of collector current IC at each step. If we plot the graph between with collector to emitter voltage VCE along the horizontal axis and collector current IC along the vertical axis, we obtain the following graph. So this figure shows the output characteristics of the common emitter configuration in a transistor. So here